This is GARIS Essays, that is 2-3-page opinion pieces on topics such as species dominance, the global state, politics, Femtotech, religion, society and education. Written by and read aloud by Prof. Dr. Hugo de GARIS. This is essay number 33, entitled Fermitech or Femtotech, searching for phenomena in physics that may serve as bases for a femtometer scale technology. By Prof. Dr. Hugo de GARIS. Email profhugodegaris@yahoo.com. Website profhugodegaris.wordpress.com. A little history. In the winter of 1990-91, I was spending 2 months in Boston, staying at an MIT frat, or fraternity, with a very young 16 years old colleague of mine, working on a connection machine, CM5, trying to evolve 3D cellular fission rules to grow a 3D embryo. During those bitterly cold months, there happened to be a meeting one evening of the MIT Nanotech Club that I thought would be interesting to attend, so I did. The meeting featured a telephone hookup Q&A session with Eric Drexler in California, generally considered to be the father of nanotech. I asked him whether he thought a femtotech might one day be possible. He pooh-poohed the idea, which struck me as odd, since he was so critical of those conservatives who pooh-poohed his vision of a nanotech, that is, molecular scale engineering, with objections such as, the Heisenberg uncertainty principle forbids it, or thermal noise would destroy the accurate positioning of atoms, etc. Drexler persisted nevertheless, wrote his famous text in 1992, and now nanotech is a thriving research field with progress being made every month. Half a decade later, I was visiting the Santa Fe Institute in New Mexico and got an opportunity to ask Murray Gell-Mann, the SFI resident genius and father of the quark, the eightfold way, charm, strangeness, the omega minus, etc. Can you think of any phenomena in physics that might be used as the basis for a femtotech? He hadn't really thought about the question, but managed to say that he had a business meeting one time to consider the possible industrial applications of the neutral kaon particles. So it should be clear from the above two instances that the question, what comes after nanotech, has been on my mind for over 2 decades. If Fermitech, or Femtotech, is not possible, then sooner or later humanity, or post-humanity, will start running up against the confines of nanotech and start itching to move down to the Fermi scale. Now that nanotech is well launched, perhaps the time is now ripe to start thinking about what's next, that is, about the possibility of a Fermitech, Femtotech as I call it now. A decade and a half later, that is now, I find myself in my early 60s. Well, I'm about to turn 70, so this must be quite an old essay. I find myself in my early 60s arcing, that is, after retirement careering, which I describe as wage-free careering in the third of life, and returning, after working 20 years on artificial brains, to my old love of mathematical physics, studying intensively PhD-level pure math and mathematical physics, with a view of writing several books on math/physics topics such as topological quantum computing and Fermitech. I'm now actively hunting down phenomena in physics at the femtometer scale that might serve as substrates to allow computation and engineering at that tiny scale. Since a femtometer, also known as a Fermi, is 10 to the minus 15 of a meter, to find such phenomena implies that one should be hunting at the nuclear, nucleon, and elementary particle levels. Hence one should be studying nuclear physics, elementary particle physics, QCD, that's quantum chromodynamics, etc. I spend my afternoons in my favourite beautiful park and my nights in my apartment studying the following subjects in pure math and theoretical physics, partly because of a deep inherent love of these topics, as well as being motivated to use this knowledge to try to find bases for a femtotech. In pure math, I'm studying finite groups, abstract algebra, Lie theory, general topology, algebraic topology, geometric algebra, smooth manifolds, complex manifolds, representation theory, ring theory, Galois theory, knot theory, quantum groups, low-dimensional topology, etc. In theoretical physics, I'm studying quantum mechanics, quantum field theory, nuclear physics, elementary particle physics, quantum electrodynamics, QED, quantum chromodynamics, QCD, special and general relativity, gauge theory, supersymmetry, SUSY, superstring theory, M theory, brane theory, conformal field theory, CFT, topological quantum field theory, TQFT, topological quantum computing, TQC, etc. At the top end of both physics, low-dimensional topology and gauge theory have merged thanks to the genius of Ed Witten, today's Einstein, and the only physicist ever to have won the coveted Fields Medal for mathematics. I call this math-physics merge Mathics. So I have my play for, undertaking an ambitious program of study and keeping an idea notebook on my desk that I'm constantly jotting ideas into. But I'm only one person. My good friend Ben Goertzel and I email each other almost daily, so inevitably I was reporting on my studies to him and got him interested in the topic. He started Googling the keyword Femtotech and started his own paper chase that he reports on in a separate essay, twin to this one. It soon became clear to me that two heads are better than one, especially when it's Ben Goertzel's head that contains a world-class brain. Ad-libbing, Ben Goertzel is actually genius. IQ measured at 186. Back to the essay. The same logic leads us both to open up the question to the general scientific public to see what N heads can come up with. Since it's likely that most of the readers of this e-zine, electronic magazine, have a computer science background, there may not be many readers who have a strong math-physics background. So if you are a CS, that's computer science type reader, can you please pass on this article to your math-physics friends and ask them if they have any suggestions as to possible Fermi-scale phenomena that might serve as the basis for a future Fermitech or Femtotech. If so, I and Ben would be most grateful and interested to receive ideas from you. Our emails are at the top, just below the title. Details. Before launching into some initial tentative suggestions for Fermi-scale phenomena that may serve as bases for a Fermitech or Femtotech, let me make a comment about picotech. Why did I jump from nanotech to Fermitech? What happened to 10 to minus 12 of a meter, that is, picometer scale technology? The obvious answer is that nature does not provide us with anything that exists at the picometer scale, unless one assembles such large Fermi-scale structures that they reach the picoscale. A typical atom has dimensions of about 10 to the minus 10 meters, that is, angstroms. The nucleus and nucleon is about 100,000 times smaller, that is, a fly in a cathedral. That is, 10 to the minus 15 of a meter, or Fermi. So nature simply does not provide any building block at the picometer scale, hence we are forced to jump down by a factor of 1,000,000 from the nanoscale to the Fermi scale. If ever a Fermitech comes into being, it will be a trillion times more performant than nanotech for the following obvious reason. In terms of component density, a Fermitech block of nucleons or quarks would be 1,000,000 cubed times denser than a nanotech block. Since the Fermitech components are 1,000,000 times closer to each other than the nanotech components, signals between them, travelling at the speed of light, would arrive 1,000,000 times faster. The total performance per second of a unit volume of Fermitech matter would thus be 1,000,000 cubed times 1,000,000 equals 1,000,000 to the fourth, that is, a trillion, and that is 10 to the power 24. I haven't even started thinking yet about possible applications of such a vast increase in capacity of Fermitech over nanotech, especially if quantum computers can be built to be robust against noise by storing bits in topological quantum fields, topological quantum computing, TQC. On the desktop of my laptop, I keep a file called Book Plans, which contains the titles of about a dozen books that I'd like to write in the hopefully 30 plus years left in my arcing life. One of those is titled Fermitech, with the same subtitle as this article. I have even written up a very tentative book plan with chapter headings where each chapter is concerned with a Fermi-scale phenomenon that just might serve as a basis for a Fermitech. I list here these phenomena and leave it to readers to use Wikipedia to learn about each topic. Please be conscious that this list is very tentative, just my first pass guess. I'm hoping after a few years of intensive study of math physics, I'll be able to create a much better list, thanks also to suggestions coming from readers of this article. Here's the list. Nuclear molecules, quark-gluon plasma, strangelets, kaons, surface of neutron stars, QCD, that's quantum chromodynamics, quarkonia, mini black holes, halo nuclei, neutron starlets, Bose-Einstein condensation of squarks, etc. Presumably, if one is to create, for example, computers at the Fermi scale, one would need to assemble large numbers of quarks or nucleons into a stable structure. Ordinary nuclei consist of protons and neutrons, but there's a limit to their size for stability reasons. The range of the strong force is only a few nucleon diameters, so one needs proportionately more neutrons per proton to counter the accumulating electric repulsion that has unlimited range. Once one reaches 92 protons, that is uranium, the nucleus is almost unstable because the cumulative electric repulsion is close to overcoming the strong force, which is only about 100 times stronger than the electric repulsion of the protons. I've noticed that once one looks upon the many phenomena of nuclear physics and QCD, one begins to see things in a new light and starts to ask questions that may not have been asked before. For example, would it be possible to assemble structures that consisted of only neutrons? A single neutron will soon decay into a proton, an electron and an antineutrino, but neutron stars seem to be stable, containing huge numbers of neutrons. A massive neutron-only nucleus kilometers across. Could one build somehow a mini or Fermi neutron star consisting only of neutrons? The above is highly speculative and probably quite amateurish and wrong, but it illustrates the kind of novel thinking that is required if ever a Fermitech is to come into being. It's easy to shoot down Aunt Sally's. It's a lot more difficult to actually find some physics loophole that would actually allow a Fermitech. There's an interesting historical analogy that may be instructive. Ever since the phenomenon of radioactivity was discovered over a century ago, physicists knew there was enormous energy contained inside the nucleus. This led many people to ask whether one day it might be possible to tap into that energy on an industrial scale. Even as late as the early 1930s, the great Rutherford, the father of the nucleus, is his term, thought the idea of industrial scale nuclear energy was, quote, moonshine. That is ridiculous. However, the Hungarian-American Jewish nuclear physicist Leo Szilard was skeptical and felt there just had to be a way to tap into that enormous nuclear energy, if only he could be ingenious enough to find a way. Well, he did, in 1933, the year after the neutron was discovered, and the same year Hitler came to power in the world's dominant scientific country, that is, Germany. Szilard's century-changing idea was to shoot a neutron with no charge, hence would not be deflected by the charge of the nucleus, into a nucleus that was almost unstable, that is, uranium. The penetrating neutron might make the nucleus unstable, which would split into two half-nuclei with less neutrons. Hence 2 to 3 neutrons would be shot out at the moment of the split, the fissioning. These neutrons could then fission other uranium nuclei. The total mass of the two half-nuclei plus outgoing neutrons would be less than the uranium nucleus plus incoming neutron. The missing mass, via Einstein's famous E equals mc squared formula, would lead to the outgoing particles having great energy. Szilard's chain reaction idea allowed him to calculate that a football-sized lump of uranium could release enough energy to vaporize a whole city. He was not only the first to dream up the idea of how to tap into the energy of the nucleus at an industrial, that is military, scale, but he was also the first to realize that Hitler might be the first to get the bomb. So, readers are asked to take heart. Don't be put off by objections to the idea of a Fermitech. If we don't go actively searching for Fermi-scale phenomena that might serve as a basis for a Fermitech, then we will be much less likely to find one. Szilard succeeded in being cynical and brilliant. Perhaps one of you may do the same for Fermitech. Who knows? One of the applications of Fermitech might be a Fermi bomb, releasing orders of magnitude more energy than the fission and fusion nuclear bombs of the 1940s and 50s. That would be capable of destroying not just cities, but whole countries. I just thought of this Fermi bomb idea now, writing this paragraph. The twin essay to this one is written by Ben Gersel, my good friend, who is more technically minded than I am. I'm more on the visionary/political side, and Ben is more on the analytical details side. So before I sign off, please email us if you are a physicist, or you know someone who has suggestions as to how to create a Fermitech. Perhaps we can list the suggestions after this article, with readers responding to earlier suggestions, and a large-scale brainstorming across the planet, such as the power of the internet. By way of a footnote, if Fermitech, that's 10 to the minus 15 of a meter, is possible, what about an attotech, 10 to the minus 18 of a meter, a zeptotech, 10 to the minus 21 of a meter, a yoctotech, 10 to the minus 24 of a meter, ... a planktech, 10 to the minus 35 of a meter. Since the smaller components are, the faster they can signal to each other, one comes to the jaw-dropping conclusion that there may be whole civilizations inside elementary particles, and that they may be the reason why we don't see signs of advanced civilizations in the cosmos, thus answering Fermi's famous question, where are they? That is, all the advanced civilizations in space who are billions of years older than the human species. Just maybe, we humans are built with such civilizations in all our constituent elementary particles. Perhaps these particle civilizations communicate with each other via quantum mechanical entanglement, that is, zero signal time, action at a distance. Maybe advanced civilizations are all around us, inside us, but are too small for us to see or even be aware of. That's it. So, cheers. Prof. Dr. Hugo de Garis. Email profhugodegaris@yahoo.com. Website profhugodegaris.wordpress.com. And YouTube channel name Hugo de Garis.